Now in our last video we were looking at some of the statistics on the network path for this call that actually was tied to a triggered event or triggered alert on our UCD box. Now we did look at some of the statistics, and I'm going to go ahead and minimize these because now we're actually going to look at digging into this little area here too, where this event actually occurred, or as UCD determined it to occur. So something that I'm going to do just by hovering, and you've probably already seen it yourself before, is that when I hover over this, kind of like before with our alert, we have these little helpful buttons here that actually show more options for how we can drill in specifically to this network path or this network issue. Now from those events, this will depend largely on your deployment. So if you have something like JFlow, or in this case Cisco is in the picture, so it's a NetFlow. If you have something like NetFlow configured, then you could use this NetFlow button to really see how much of each type of traffic, whether source, destination, or applicable application that was actually generating or receiving it, really came from. We can also drill into QoS. So if that's being monitored by the network and QoS is being picked up by UCD as something that is monitoring, then we can actually look at QoS for this specific event here. Same with if we wanted to explore more specifically about the topology. Though I find for me personally that in looking at UCD and using it to troubleshoot issues, more often than not, I'm usually going and traveling down into NetFlow and QoS. So let's go ahead and start off with the NetFlow piece. Now by now, the takeaway should be that every time I click this little drill down button where it gives me the option to search even further, something that UCD does that, well, I really love is that it fills in, or it auto-populates all of these fields that I need to do to search for this issue that's tied to that event. Now in this case, I'm not going to change a thing here, but looking back again to see what it's really telling me, in this case, this is saying that, okay, SVP, meaning the UCD-P role specifically, we can see that it came, or it was picked up from this specific UCD box, and it's tied to this router on this router's interface. We don't have any kind of filter here going on, but we do have a time frame that's auto-filled in for us, as well as we're searching by specific types. In this case, IP version 4 NetFlow, and we're looking at these specific attributes when it comes to our NetFlow source. Now, probably way too much information. The big thing to really keep in mind is that this gets auto-populated in for your search, and then you just have to hit submit. Now you might be looking at this and thinking, okay, so I just hit search, now what? Well, now this is really something where you could probably take a look at this and really match it to something that the network team is really handling. Now a way to look at this, or a way to interpret this graph, is also by not only this view here, but also the results tab. But starting off in the graphs view, if you take your mouse and you hover over the legend, then you can see that what you're really looking at here, this color coding, is actually color coding as seen by different traffic sources. So for example, that light orange at the very top, it's basically traffic that's coming from a router or a destination point at an IP address of 4.0.0.20. Same thing with the green below that. We can see that this is actually traffic that's going in from 4.0.0.3. Now, in terms of just looking at this, you might be thinking, okay, that's great, that's traffic. Well, what is it really telling me? Well, in this case, what it's actually telling us is that 30% of the pipe was really being taken up by, well, not both of these together, but really, this is how much of a percentage that these traffic points, or these addresses, are really either sending or receiving on this link. So already, that's about 30% right here from just this IP address alone. And then there's almost another 30 from this one. So already that's 60% of our pipe. Now, if you look at these other ones and combine them here too, that's about rather almost 15% here, 12% there, close to 30 when you look at the rest of these. So really, in actuality, when you combine these percentages and these views up, that's almost 100% of our pipe between all of these sources. Now, this isn't so much helpful unless you're just looking to determine what specifically is taking up the most bandwidth. It's really good for determining that, especially if you have a thirsty or hungry application that's hogging up the network. Something you can also use, though, to supplement this is that you get actually the actual packet or octet count based off of these sources here with timestamps associated. Now, from this troubleshooting standpoint, and really from a UC monitoring standpoint, this information is really helpful, especially when your team is coupled very close with your network team, but oftentimes it's not always the best way to really look at what might be causing the issue in terms of network configuration. In fact, a lot of times, at least in my experience, I've run into issues where there's been either incorrectly configured QoS policies or priority queues that are actually dropping QoS from one side. So recall though that we started off with a couple of options to drill down. One was NetFlow, one was QoS, one was topology. Let's go ahead and close this, and we're going to go back to our event, and now we're going to drill into QoS. Now we'll look at a couple of different ways that we can look at QoS beyond just this view. We don't always have to wait for an event to come in, but for now, we're just going to stick to the guns on what we're going with here. And we know that our query information or our search information is auto-populated for us. I'm just going to go ahead and cut right to it and say submit. Okay, now something to take away too here also is that whenever you hit submit, it's always going to go to a graph view by default first if it has that option tied to that search. In this case, QoS and NetFlow almost always does. Now here what we're looking at is this is the rate of packet drop. Now this isn't so much tied to QoS, but rather tied to the side effects of incorrect QoS, and that's just speculation for right now. But hovering over our legend text here with our mouse, we can see that we are at least given a breakdown of how much of this link is being taken up by things like data traffic at the link level, or Skype traffic specifically, or really SIP traffic independent of itself. SCCP, that's actually a skinny protocol, so if we have a Cisco system that's in the mix, then we can expect that to be there too. And then everything else that's really just tagged with default, or N, is marked in red down below. Now, something that's kind of interesting about this is that this graph is definitely helpful. However, when looking at QoS specifically, something that's very powerful about UC Diagnostics and how it monitors the network is its ability to see what the priority queue size for QoS is on a router. Now, I've gone ahead and switched to our results view, and I'm going to just widen this table a bit. But let's take a look at our data here, and we're actually going to look at interpreting this based off of a QoS configuration. Now, something that I love that's really cool here, and no, it's not timestamp, it's looking at each one of these and knowing that these names, like for example, link level, Skype P, SIP P, Skinny P, or SCCPP, and then class default N. These are actually names that UCD is picking up from a monitored router of QoS priority queue names. Now, the percentages that go along too is also not something that's entered in manually. This is actually something that UC Diagnostics is seeing. So what this means is that UC Diagnostics is basically looking at this router that we searched against here, this Dallas CE1, on this specific interface, and it's saying, all right, voice knock monitoring person, I can see that we have QoS configured on this interface here. And the QoS priority queues, and this is huge, is basically link level, Skype, which is configured for 10% priority, SIP, which is configured for 10% priority, Skinny, which gets 7, and then class default, which is 0 because it's just default. Now, take a look though, we now know our priority queue sizes, but looking down below, we can actually see the thresholds of how much of that queue was actually taken up. So if we have 10% for Skype, that means looking at this, yeah, we're getting kind of close here in terms of traffic, but these numbers are actually 6.74 here, 6.93%, 6.72. That's basically 6.72% of the pipe, and we're not hitting that 10% cap on this pipe or this connection. That's another way to refer to it as a pipe. Now, you take that information though, and you look back here at the SIP table, and we can see that we get some different information or some different results though. So keep in mind that for SIP, and we'll actually use Skinny too because I see something here that's catching my eye. For SIP and Skinny, we have 10% and 7% set respectively. But take a look at these numbers. We're hitting 11.2%, 11.2%, 11.21, and then with Skinny, we're hitting 7.62, 7.52. Now, depending on the type of QoS that is actually set on this router, if it's something like what's called a policing queue, then that basically means that QoS says, okay, I'm going to guarantee this type of traffic here and here, 10% and 7%. Oh, you're at 11.2. I can't guarantee anything over 10. And if it's something like a policing priority queue configuration, then it probably might be just dropping these packets on this. But either way, whether it's dropping specifically from this bucket or not, something to take away is that QoS is paramount in terms of a UC environment. So here we can already see that we have a SIP queue, which is already oversubscribed on this priority queue size. So this is something that we would want to either, if we were part of our network team, then we could reconfigure ourselves and either add some bandwidth or redo some things going on with our priority queue size for QoS. Or we could take it to a network team and say, look, I can see that we have only 10% SIP traffic configured to be allowed to go on this pipe, but we're hitting 11.2. We got to do something to change that. Otherwise, we're going to have calls with drop packets continuing to go on. So that's really the power in drilling down into UC diagnostics calls that are monitored and looking at things like NetFlow and QoS as we get a whole lot more visibility into things like what's really going on with QoS, not just is it configured yes or no.